Question 1. In the context of asbestos abatement, Mr. Thompson is preparing to remove insulation from HVAC ductwork in a commercial building. He observes that some insulation appears friable while the sections are intact but aged. What should Mr. Thompson do first to ensure safety and compliance? A. Immediately start wet removal of all insulation. B. Conduct a thorough inspection and sampling to identify them and pack them. C. Seal the entire HVAC system without identifying specific materials. D. Apply a general-purpose encapsulant to all duct insulation. Answer. Correct answer. B. Detailed explanation. The first step must be a proper identification and assessment of AAM and PACM to comply with OSHA and EPA requirements. Sampling allows the supervisor to differentiate friable versus non-friable materials, determine asbestos concentration, and plan the appropriate abatement method. Immediate removal without identification risks uncontrolled fiber release, regulatory violations, and worker exposure. Sealing without analysis or blanket encapsulation may leave hazardous materials untreated, compromise containment, and reduce abatement efficacy. Following proper sampling ensures safe, compliant project planning. Question 2. Considering the evidence Patel is designing a negative pressure containment for a multi-story HVAC abatement project, she must ensure proper airflow to prevent asbestos fiber migration. Which approach best achieves this goal? A. Place HEPA units outside the work area and rely on natural airflow. B. Install properly sized negative air machines within containment with exhaust through HEPA filters. C. Use only physical barriers without air filtration as containment alone is sufficient. D. Open doors intermittently to balance pressure differences between floors. Answer. Correct answer. C. Detailed explanation. Relying solely on physical barriers without negative pressure and HEPA filtration does not effectively prevent fiber migration. Proper negative pressure systems correctly sized for the volume of the containment maintain inward airflow, preventing fibers from escaping. Incorrect placement or lack of filtration undermines containment integrity. Randomly opening doors or relying on natural airflow violates protocols, increases cross-contamination risks, and compromises regulatory compliance. Effective engineering controls are foundational to worker and public safety. Question 3. Given the circumstances, Mr. Lewis notices workers improperly removing asbestos-containing pipe insulation using dry methods, creating visible dust clouds. What is the most appropriate corrective action? A. Ignore the procedure since the area is already posted as regulated. B. Stop work, enforce wet removal techniques, and retrain staff on proper methods. C. Increase ventilation without modifying removal practices. D. Encourage workers to wear standard coveralls instead of respirators. Answer. Correct answer. B. Detailed explanation. Dry removal of friable asbestos produces airborne fibers that dramatically increase exposure risk. Stopping work, enforcing wet removal, and retraining staff aligns with OSHA and NESHAP standards. Ignoring improper techniques or merely increasing ventilation does not adequately control fiber release. Standard coveralls without respirators do not protect respiratory health. Supervisors are responsible for correct and safe practices immediately to maintain compliance, protect health, and prevent project liability. Question 4. When evaluating the merits of a medical surveillance program, Sanchez must decide which employees require enrollment. Who should be included? A. All office staff in the building regardless of exposure. B. Workers exposed above permissible exposure limits or action levels for asbestos. C. Only employees directly handling AAM. D. Temporary contractors visiting the site without asbestos contact. Answer. Correct answer. C. Detailed explanation. OSHA requires enrollment in medical surveillance programs for any worker exposed at or above action levels for asbestos, regardless of whether they directly remove material. This proactive monitoring identifies early health effects such as asbestosis or mesothelioma. Including non-exposed office staff or temporary visitors is unnecessary and inefficient. Limiting to direct handlers alone can miss indirect exposures in regulated areas. Correct enrollment ensures compliance, worker protection, and early detection of asbestos-related health issues. Question 5. From a practical standpoint, ISTICA must decontaminate an HVAC system after asbestos abatement. Which procedure best minimizes residual fiber contamination? A. Wipe surfaces with dry rags. B. Use HEPA vacuums, wet wiping and post-abatement air sampling. C. Open the HVAC system to flush air naturally. D. Apply a standard household disinfectant inside ducts. Answer. Correct answer, D. Detailed explanation. Using standard disinfectants or dry wiping does not capture asbestos fibers and risks fiber resuspension. Effective decontamination relies on HEPA vacuums, wet wiping, and validated post-abatement clearance testing. This combination ensures that airborne and settled fibers are removed, surfaces are safe, and the area meets regulatory clearance standards. Opening systems without containment can spread contamination, violating safety protocols. Proper decontamination protects both future occupants and maintenance personnel. Question 6. Through careful analysis of a demolition project, Rivera observes asbestos-containing ceiling tiles mixed with non-friable panels. What is the correct approach to handle these materials? A. Remove all ceiling tiles using dry scraping for speed. B. Differentiate them from non-USCM and apply appropriate wet removal or encapsulation. C. Burn non-friable tiles and discard AAM in regular waste. D. Leave AAM in place and rely on general cleaning after demolition. Answer. Correct answer, C. Detailed explanation. Differentiating EM from non-USCA is crucial to comply with OSHA EPA and NESHAP standards. Wet removal or encapsulation reduces fiber release during abatement. Dry scraping of AAM is unsafe, burning is illegal, and leaving AAM in place poses long-term exposure risks. Proper segregation, labeling, and disposal of asbestos waste prevent regulatory violations, ensure worker safety, maintain environmental compliance. This strategic approach is essential for safe demolition practices. Question 7. During the process of a glove bag removal, Mr. Garcia notices minor tears forming in the plastic enclosure around a pipe. What is the correct supervisory response? A. Continue removal as long as workers are wearing respirators. B. Stop work, repair or replace the glove bag and verify negative pressure containment. C. Ignore small tears because they are negligible in risk. D. Increase airflow in the room to dilute fiber concentration. Answer. Correct answer. A. Detailed explanation. Minor tears in a glove bag compromise containment and pose an immediate risk of fiber release. Supervisors must stop work, repair or replace the glove bag and ensure negative pressure is maintained to contain fibers. Continuing work without addressing the tear violates OSHA containment rules, exposes workers to hazardous fibers, and may result in regulatory penalties, increasing room airflow without repairing. Glove bag does not prevent fiber migration and is insufficient for safety compliance. Immediate corrective action maintains project integrity. Question 8. While examining a renovation project, Chen identifies suspect asbestos gaskets in HVAC duct flanges. What is the best initial step to manage these materials safely? A. Remove all gaskets immediately using dry tools. B. Sample and confirm asbestos content, then plan removal or encapsulation. C. Spray gaskets with general purpose paint to seal fibers. D. Ignore the gaskets since they are a small component. Answer. Correct answer. B. Detailed explanation. Small components like gaskets require sampling to confirm asbestos content before any removal. Dry removal risks uncontrolled fiber release, while coating without verification may not fully contain fibers. Ignoring the gaskets leaves a persistent source of exposure. Proper identification enables supervisors to select correct glove bag or wet removal techniques, comply with OSHA and NESHAP standards, protect worker and public safety. Correct planning reduces risk and ensures abatement compliance. Question 9. In light of recent developments, Isterani was planning waste disposal for completed HVAC abatement project. What measures must be strictly followed? A. Bag label and transport asbestos-containing waste per local, state, and federal regulations. B. Combine asbestos waste with general construction debris for efficiency. C. Dispose of AAM at any nearby landfill without labeling. D. Burn AAM on site to reduce volume before disposal. Answer. Correct answer. C. Detailed explanation. Asbestos waste is highly regulated. Packaging must use leak-tight bags properly labeled and transported to licensed disposal facilities. Combining it with general debris, disposing at unapproved sites or burning is illegal, creates public health hazards, and violates OSHA and EPA rules. Supervisors must ensure documentation and manifests accompany all transport. Mitigates liability, prevents environmental contamination, and demonstrates adherence to safe asbestos abatement protocols. Question 10. Illustrated by Mr. Ahmed's post-abatement inspection, clearance testing shows few isolated fibers above permissible limits in the HVAC system. Which action best addresses this situation? A. Restart the HVAC system and monitor occupants for symptoms. B. Perform additional HEPA vacuuming, wet cleaning, and retest until clearance is achieved. C. Ignore the readings since the concentration is minimal. D. Apply disinfectant and reopen the area immediately. Answer. Correct answer, D. Detailed explanation. Clearance testing ensures an area is safe for reoccupation. Any detection above permissible limits indicates residual asbestos contamination. Restarting HVAC, ignoring readings, or using disinfectants alone does not remove fibers and risks exposure. Proper remediation requires HEPA vacuuming, wet cleaning, and repeated air sampling until concentrations are below regulatory thresholds. Following strict clearance protocols protects workers and occupants, ensures compliance with OSHA and AAS guidelines, and confirms that the abatement process is successfully completed. Question 11. Under the assumption that Mr. Dawson is supervising an asbestos abatement in a SKU HVAC system, he notices several workers entering the containment without performing decontamination procedures. What is the most appropriate immediate action? A. Issue a verbal warning but allow work to continue. B. Stop all work, enforce proper decontamination, and retrain staff on procedures. C. Allow workers to proceed if they are wearing respirators. D. Post additional signage without changing the work process. Answer. Correct answer, B. Detailed explanation. Decontamination is critical to prevent the spread of asbestos fibers outside regulated areas. Allowing bypassing procedures, even with PPE, risks environmental contamination and regulatory violation. Immediate work stoppage, reinforcement of protocols, and retraining ensure containment integrity in compliance with OSHA 29 CFR 1926.1101 and NESHAP. Simply posting signs or issuing verbal warnings is insufficient to protect workers or the public and does not mitigate fiber tracking risks. Question 12. When evaluating the merits of a negative pressure setup in a multi-zone HVAC abatement project, it observes fluctuations in airflow readings. Which approach best maintains safe containment conditions? A. Ignore minor fluctuations since HEPA filters are in place. B. Just negative air machines and verify pressure differentials continuously. C. Open containment doors periodically to balance airflow. D. Use fans outside the containment to create airflow without negative pressure. Answer. Correct answer, B. Detailed explanation. Maintaining consistent negative pressure ensures inward airflow, preventing asbestos fiber escape. HEPA filters alone are insufficient if airflow fluctuates. Irregular monitoring and adjustment are required. Opening doors or using external fans without controlling pressure undermines containment integrity. Proper engineering controls, verified and documented, comply with OSHA and EPA NESHAP standards and prevent cross-contamination, protecting both workers and the surrounding environment. Question 13. From a practical standpoint, Mr. Alvarez is planning asbestos waste transport from a large HVAC removal project. Which procedure is compliant with regulatory standards? A. Bag label and transport AM to an approved disposal facility following federal and state guidelines. B. Combine ECM with construction debris for faster disposal. C. Transport ECM in open containers to minimize handling. D. Burn ECM on site before disposal. Answer. Correct answer, A. Detailed explanation. AIM is highly regulated. The packaging must be leak-tight labeled and sent to licensed disposal facilities with appropriate documentation. Combining with other debris, using open containers, or burning violates OSHA, EPA, and NESHAP regulations, endangers workers, and risks legal penalties. Proper handling ensures safe containment, prevents fiber release during transport, and maintains environment compliance. Supervisors must ensure manifests accompany all waste movements. Question 14. Considering the evidences Morales is designing an asbestos abatement plan for HVAC insulation, she must choose between wet removal, glove bag, or encapsulation techniques. What should guide her decision? A. Cost reduction as the primary factor. B. Material type, friability, location, and potential fiber release. C. Worker preference without assessing hazard. D. Using the quickest method to finish the project faster. Answer. Correct answer. B. Detailed explanation. Selection of removal techniques must be based on material type, friability, location, and likelihood of fiber release to ensure safety and compliance. Wet methods and glove bags reduce airborne fibers, whereas encapsulation may be appropriate for non-friable AAM. Cost or speed alone cannot override safety considerations. Following OSHA, AHRA, and NESHAP guidelines ensures that workers, the public, and the environment are protected while maintaining project integrity and regulatory adherence. Question 15. In what ways can Mr. Hernandez verify the effectiveness of post-abatement HVAC cleaning? A. Conduct visual inspection only. B. Perform HEPA vacuuming, wet cleaning, and clearance air sampling until standards are met. C. Assume cleaning is effective if no visible dust remains. D. Restart HVAC system immediately after removal without testing. Answer. Correct answer. D. Detailed explanation. Clearance testing ensures that all asbestos fibers have been removed to safe levels. Visual inspection alone may miss microscopic fibers. Restarting HVAC without testing risks fiber spread throughout the building. Proper post-abatement protocols require HEPA vacuuming, wet cleaning, and validated clearance air sampling, aligning with OSHA and AHRA guidance. Ensuring thorough verification protects maintenance staff and maintains regulatory compliance. Question 16. Through the lens of project planning, Brown must schedule HVAC system shutdowns to minimize disruption while performing asbestos abatement. Which approach best balances safety and operational needs? A. Perform abatement during normal operation to save time. B. Coordinate full system isolation with lockout agar and containment during non-occupancy periods. C. Keep HVAC running with partial work areas cordoned off. D. Delay shutdown until after project completion to avoid downtime. Answer. Correct answer. C. Detailed explanation. Partial shutdown or failure to isolate the HVAC system can allow asbestos fibers to migrate beyond the containment area. Full system isolation with lockout agar during controlled periods ensures worker safety, prevents fiber spread, and maintains regulatory compliance. Performing abatement during normal operation or delaying shutdown jeopardizes occupants, violates standards, and liability. Strategic scheduling balances operational needs with rigorous containment and airflow control. Question 17. Illustrated by Mr. Singh's inspection, some HVAC duct gaskets appear damaged and potentially contain asbestos. What is the correct first step? A. Remove all gaskets immediately with dry tools. B. Sample and confirm asbestos content before selecting removal or encapsulation methods. C. Cover damaged gaskets with tape to seal fibers. D. Ignore minor gasket damage, assuming fibers are minimal. Answer. Correct answer. B. Detailed explanation. Verification through sampling ensures that the material is EM before handling. Immediate dry removal risks uncontrolled fiber release, while temporary coverings do not guarantee containment. Ignoring minor damage poses long-term exposure risks. Confirmed identification allows supervisors to implement glove bag or wet removal techniques in compliance with OSHA and NESHAP, ensuring worker and environmental and proper project planning. Question 18. While examining the consequences of HVAC duct cleaning, Carter finds residual asbestos on fan blades despite previous abatement. Which is the most appropriate corrective measure? A. Restart the system to disperse fibers for final cleaning. B. Perform additional wet cleaning and HEPA vacuuming, followed by retesting. C. Ignore residual fibers if small in quantity. D. Apply disinfectant and declare the system safe. Answer. Correct answer. C. Detailed explanation. Any residual asbestos detected in HVAC components indicates incomplete cleaning. Restarting systems or using disinfectants does not remove fibers and risks exposure. Recleaning with wet methods and HEPA vacuuming combined with clearance air sampling ensures compliance with OSHA, AHRA, and NESHAP standards. Ignoring contamination, regardless of quantity, violates safety requirements and places and building occupants at risk. Correct remediation is essential for confirmed clearance. Question 19. Given the circumstances, Mr. Jordan is monitoring worker PPE compliance on an abatement project. What is the most critical factor to enforce? A. Full respirator fit testing, correct coverall use, and consistent PPE protocol adherence. B. Allowing workers to choose PPE based on comfort. C. Requiring PPE early in visible high dust areas. D. Limiting respirator use to supervisory staff. Answer. Correct answer. A detailed explanation. Respiratory protection and PPE are essential to prevent asbestos exposure. Full fit testing, proper coverall use, and consistent adherence across all regulated areas ensure worker safety and regulatory compliance. Allowing choice, partial use, or selective enforcement increases exposure risk and violates OSHA 1926.1101 standards. Supervisors are responsible, enforcing comprehensive PPE protocols, training workers, and maintaining documentation to protect health and maintain project safety integrity. Question 20. The primary reason for conducting pre-abatement HVAC inspections, as Mr. Evans demonstrates, is to A. Identify locations of AAS, determine abatement strategy, and plan airflow control. B. Schedule maintenance without assessing asbestos risk. C. Reduce cost by assuming all materials are safe. D. Allow workers to start removal without containment preparation. Answer. Correct answer. D. Detailed explanation. Pre-abatement inspections locate AAS, assess friability, and inform the abatement plan, including containment design and negative airflow placement. Skipping inspection or assuming safety jeopardizes worker and occupant health, risks regulatory non-compliance, and compromises project outcomes. Inspections enable targeted removal, safe sequencing, and proper scheduling, ensuring that engine controls, PPE, and waste management are correctly applied. Thorough planning is fundamental to effective asbestos abatement. Question 21. In the modern context of HVAC abatement is new and discovers friable asbestos in boiler insulation that must be removed while minimizing fiber release. Which method should she prioritize? A. Dry scraping with minimal containment. B. Wet removal using glove bags and negative pressure containment. C. Encapsulation without prior identification. D. General surface painting to seal fibers. Answer. Correct answer. B. Detailed explanation. Wet removal combined with glove bags and negative pressure containment is the safest, regulatory compliant method for friable AAS. Dry scraping or painting risks uncontrolled fiber release. Encapsulation without identification may leave hazardous materials untreated. OSHA 1926.1101 and EPA-NESHAP guidelines emphasize wet methods and containment to protect workers and building occupants. Correct application minimizes airborne fiber exposure and ensures safe abatement while allowing accurate clearance testing. Question 22. Given the circumstances, Mr. Patel observes that workers are about to start HVAC duct removal without verifying EM presence. What should he do first? A. Begin removal to stay on schedule. B. Perform a detailed AAS inspection and sampling prior to removal. C. Assume all materials are safe and proceed. D. Use HEPA vacuums while removing ducts without containment. Answer. Correct answer. B. Detailed explanation. OSHA and AHRA regulations mandate identification of AIM before any abatement activity. Sampling differentiates EM from non-AAS, informs removal techniques, and ensures compliance with NESHAP. Proceeding without verification risks fiber release, worker exposure, and regulatory violations. HEPA vacuuming alone does not prevent airborne fibers without proper containment. Correct identification allows safe method selection and ensures environmental and personnel safety throughout the project. Question 23. In what ways can Isotauras ensure worker safety when asbestos is present in HVAC system gaskets during maintenance? A. Allow workers to handle gaskets with standard gloves only. B. Implement glove bag procedures, wet removal, and respiratory protection. C. Ignore gaskets, assuming small size limits exposure. D. Use general cleaning methods with it. PP. Answer. Correct answer. C. Detailed explanation. Even small components like gaskets can release asbestos fibers if mishandled. Glove bag procedures, wet removal, and proper PPE are necessary for safe handling. Ignoring materials or relying on standard gloves without respirators compromises worker safety and violates OSHA 1926.1101. Supervisors must ensure containment and adherence to protective protocols. Methods reduce airborne fiber risk, maintain compliance, and protect both maintenance personnel and building occupants from long-term exposure. Question 24. Through careful analysis of project planning, Mr. Simmons must schedule HVAC system shutdowns for asbestos abatement. Which approach balances safety with operational efficiency? A. Conduct abatement while systems remain operational. B. Coordinate full shutdown with lockout and containment during low occupancy periods. C. Isolate only part of the system while work continues elsewhere. D. Delay shutdown until final project stages to reduce downtime. Answer. Correct answer. B. Detailed explanation. Full HVAC shutdown with lockout ensures containment integrity, prevents fiber migration, and protects workers. Partial shutdown or continued operation increases exposure risk and violates OSHA regulations. Delaying shutdown compromises safety. Proper planning considers system airflow, containment setup, and building occupancy, balancing operational needs with safe, compliant abate practices. This approach ensures both efficiency and adherence to regulatory standards. Question 25. Demonstrated by Is Johnson's inspection, post-abatement air sampling shows detectable fibers above permissible limits. What is the correct next step? A. Restart HVAC system and reoccupy building immediately. B. Conduct additional HEPA vacuuming, wet cleaning, and retest until clearance standards are met. C. Ignore readings if fiber levels appear minimal. D. Apply general disinfectant and reopen area. Answer. Correct answer. D. Detailed explanation. Residual asbestos above permissible levels indicates incomplete abatement. Restarting HVAC or applying disinfectants alone does not remove fibers. Effective remediation requires thorough wet cleaning, HEPA vacuuming, and repeated clearance sampling until results meet OSHA and AAS standards. Ignoring contamination risks fiber dispersion, occupational exposure, and regulatory non-compliance. Supervisors must ensure corrective actions are implemented and validated before reoccupancy. Question 26. In the absence of proper containment, ISTA-CHEM plans to remove asbestos pipe insulation in a large HVAC system. What is the safest method? A. Dry removal with minimal PPE. B. Utilize glove bags, wet removal techniques, and negative pressure containment. C. Encapsulate without identification. D. Leave fibers in place and rely on ventilation. Answer. Correct answer. B. Detailed explanation. Glove bags and wet removal with negative pressure ensure fibers are captured and do not migrate into occupied spaces. Dry removal or relying solely on ventilation allows uncontrolled fiber release and violates OSHA 1926.1101 and EPA-NESHAP rules. Encapsulation without verification risks incomplete abatement. Correct containment and removal strategies maintain safety, environmental compliance, and ensure the HVAC system can safely resume operation after clearance testing. Question 27. Through the lens of worker protection, Is Alvarez notices respirators are being worn incorrectly during asbestos removal. What is the correct supervisory action? A. Allow workers to continue if discomfort is noted. B. Stop work, perform fit testing, and retrain on correct respirator usage. C. Issue additional disposable coveralls without addressing respirators. D. Lit PPE enforcement to high dust areas only. Answer. Correct answer. C. Detailed explanation. Respirator misuse negates protection and poses serious health risks. Supervisors must halt work, conduct fit testing, and retrain staff per OSHA respiratory protection program requirements. Simply issuing coveralls or enforcing PPE selectively does not prevent fiber inhalation. Correct respiratory protection combined with containment, decontamination, and proper work practices is essential. Compliance, worker safety, and mitigating long-term asbestos-related health risks. Question 20. Considering the evidence Mr. Foster finds asbestos-containing HVAC duct mastic during renovation, which action ensures safety and regulatory compliance? A. Remove all mastic with dry scraping. B. Sample and confirm asbestos content, then use wet removal or encapsulation. C. Cover mastic with paint without verification. D. Ignore mastic assuming low exposure risk. Answer. Correct answer. B. Detailed explanation. Proper identification through sampling informs safe handling methods. Wet removal or encapsulation reduces fiber release risk. Dry scraping or unverified coatings can release hazardous fibers, violating OSHA 1926.1101 and EPA NESHAP. Ignoring the material leaves exposure risk for workers and building occupants. Supervisors must develop an abatement plan that addresses type, friability, and location, ensuring worker protection and regulatory compliance. Question 29. From multiple perspectives, Evans evaluates glove bag used for small HVAC pipe fittings. What is the main advantage of this method? A. It allows dry removal without fiber containment. B. It enables controlled removal in a sealed environment, minimizing airborne fibers. C. It eliminates the need for PPE. D. It reduces compliance documentation requirements. Answer. Correct answer. C. Detailed explanation. Glove bags provide a sealed environment for removing small AAS components, capturing fibers, and preventing spread. They do not eliminate the need for PPE or regulatory documentation. Workers must still wear respirators and coveralls. Dry removal without containment or assuming compliance is unnecessary, exposes workers. Using glove bags correctly enhances safety, reduces fiber release, ensures abatement meets OSHA and NESHAP standards, making it an essential technique for HVAC-specific asbestos removal. Question 30. While analyzing airflow dynamics, Mr. Reynolds must position negative air machines for a multi-level HVAC abatement project. Which principle best guides placement? A. Place units randomly in the containment area. B. Locate units to maintain inward airflow from clean areas into the regulated zone and exhaust through HEPA filters. C. Use negative air machines outside the building. D. Position units near exits to push fibers outward. Answer. Correct answer. D. Detailed explanation. Proper placement of negative air machines ensures inward airflow from clean to regulated areas and exhaust through HEPA filtration, preventing fiber migration. Random placement or exhausting near exits compromises containment and risks building contamination. Units outside the building or pushing fibers outward violates OSHA, AHRA, and NESHAP guidelines. Correct engineering control design is critical, maintaining negative pressure, worker protection, and ensuring successful clearance testing before reoccupancy.